The topic of this pencast is dividing decimals. My name is Darren Lacoste. Let's start with a problem. The instructions say divide and check. Negative 2.808 divided by negative 104. So there are a few things that we want to keep in mind when we're solving this problem. First, when the division symbol is used, the first number, which we call the dividend, goes under the division bar. Next, we've got a negative divided by a negative, which we recall will result in a positive answer. The last thing we want to take into account is that the decimal in the quotient, which is the answer to our division problem, will go directly above the decimal in the dividend. Okay, so negative 2.808 divided by negative 104. We know our answer is going to be positive, so let's just ignore both of those negatives for now. We're going to put 2.808 underneath the division bar. Remember, that's our dividend. And we're going to put 104 to the left. That's our divisor. Now, long division with decimals is really the same idea as long division in using whole numbers. But we have to keep in mind that we have this decimal and we're going to have to deal with that. The instruction said that the decimal in the quotient, which is our answer, will go directly above the decimal in the dividend. So let's go ahead and place that now so that we don't lose track of it. We're ready to begin the division process. We want to know how many times does 104 divide into 2808. And I've said 2808 on purpose because we're treating these as though they were whole numbers. We know they're decimals, and we've put the decimal in the right place to take that into account. But we're thinking of this in terms of whole numbers. So we're thinking, how many times does 104 go into 2808? Well, we want to work from left to right. We take a look at our divisor and say, how many times does 104 go into 2? Well, it doesn't. 2 is a much smaller number than 104. So we put a 0 directly above the 2. Let's consider now a second digit. Since we didn't get anything out of the 2, let's see if we can do something with the 28. How many times does 104 go into 28? Again, the answer is 0 because 28 is less than 104. So we put a 0 directly above the 8. Finally, we add the third digit. Now we're considering 280. How many times does 104 go into 280? Well, 104 is pretty much close to 100. 280, that's close to 300. It's less than 300. It's more than 200. So it's very likely that our answer here is either going to be 2 or 3. It turns out that 2 will be the correct answer. So let's go ahead and give that a shot. We'll write our 2 up here. Now underneath, we're going to multiply that 2 by the 104, one digit at a time. 2 times 4 gives me 8, so I place the 8 underneath the 0. 2 times 0 gives me 0, so I place the 0 underneath the 8. 2 times 1 gives me 2, so I write the 2. Now we subtract. I can't take 8 from 0, so I have to borrow. I'm going to change this 8 into a 7. And that means that I can add 10 to the 0, which turns it into a 10. 10 minus 8 is 2, 7 minus 0 is 7, 2 minus 2 is 0. I'm left with 72. Now at this point, we want to make sure that our remainder is less than our divisor. 72 is less than 104, so that we know we've chosen the correct number. 2 was the right number. But we're not done with our problem. We still have a 72, and that's not 0, so we have to keep going. The next step is to bring down this 8. When we do, now we're trying to find out how many times 104 goes into 728. Well, 104, again, is close to the number 100. 728 is close to the number 700. 100 goes into 700 7 times, so let's try 7. It might work, it might not. Let's find out. So we'll place the 7 up here. And now we need to multiply. 7 times 4 is 28. So I'll write the 8 and carry the 2. 7 times 0 is 0. Add the carried 2 and we have a value of 2. 7 times 1 gives 7. Look at that. We got 728 exactly. When we subtract, now we have a remainder of 0. And we know we have finished our division problem. But the instructions for this problem said to divide and check. So in order to do that, we want to multiply the answer of our problem, the quotient, by our divisor, which was 104. So let's check and make sure we got the right answer. If we do, when we multiply those together, we should get our dividend back. Remember, that was 2.808. So let's write. We have 104, and that's being multiplied by 0.027. Now, if you're unfamiliar how to do multiplication with decimals, then I urge you to take a look at the pencast that I created on multiplying decimals, because we're going to use those skills now. Let's begin. So we begin with the rightmost digit in the bottommost factor, which is 7. 7 we multiplied by the factor above. 7 times 4 is going to give me 28. So I'll write the 8 down here and carry the 2. 7 times 0 is 0, plus the carried 2. So I write down the 2. 7 times 1 is 7. So my first partial product is 7 to 8. To continue to the next digit, which is the 2, I now need to put a placeholder 0. Once I've got that, I can continue. 2 times 4 is 8, nothing to carry. 2 times 0 is 0, nothing to carry. 2 times 1 is 2, nothing to carry. Now that's all of my digits in my bottom factor. Everything else is a 0. It won't contribute to my final sum. So I'll go ahead and draw my line and add my partial products together. 8 plus 0 is 8. 2 plus 8 is 10, so I'll write a 0 and carry a 1. 7 plus 0 is 7, plus the carried 1 gives me 8. And 2 doesn't have anything to be added, so it simply comes down. So I have 2808. Now I'm not done. Anytime you ever multiply decimals, the number of decimal places in the answer comes from the sum of the number of the decimal places in each factor. Well, 104 doesn't have any decimal places, because the 0 is to the right of the 4. So we find that this has 0 decimal places. The bottom factor has 3 decimal places, because to the right of the decimal are 3 digits, a 0, a 2, and a 7. So the number of decimal places on our final answer for this problem should be 3, because 0 plus 3 gives us 3. To find out where that is, we start at the right side and move 1, 2, 3 spaces to the left. That will give us 3 decimal places. So our final answer for this problem is 2.808. Let's try another example. Okay, this problem says divide 1.976 divided by 0.16. There are 3 things that we want to know to be able to complete this problem. The first is that when the division symbol is used, the second number, which we call the divisor, is not allowed to have a decimal when we're using long division. If that divisor does have a decimal, we need to move the decimal point in the divisor to the far right, counting the spaces along the way. Then we move the decimal point in the dividend the same number of spaces to the right. Once we do that, we'll be dealing with a whole number divisor. If you run out of digits in the dividend, but you still have a remainder, add a 0 to the end of the dividend, bring it down, and keep dividing. Okay, so the first thing we want to do is make sure that we get our digits in the right place. This problem was 1.976 divided by 0.16. Divided by 0.16 means that 0.16 is doing the dividing. It is the divisor, and therefore it has to go on the left. So when we draw our division bar, we have 1.976 underneath the division bar, and 0.16 to its left. Notice that our divisor has a decimal. We're going to have to do something about that. So we're going to move the decimal in the divisor all the way to the right, counting spaces along the way. There were 2 spaces. To compensate for moving that, now we're going to move the decimal point in our dividend the same number of spaces to the right. 1, 2. So that will end up between the 7 and the 6. Okay, now we're ready to do our division. Let's rewrite our problem. So we've got a whole number divisor, which is 16, and that's being divided into 197.6. Notice that our decimal point and our dividend has moved between the 7 and the 6, just like we said that it would. Alright, so let's go ahead and perform the division. 16 does not go into 1 because 1 is smaller than 16, so we can put a 0 up here. And before we forget, whenever you are using long division involving decimals, you should always put the decimal point in your answer directly above the decimal point in your dividend. Alright, so 16 Doesn't go into 1, but it does go into 19 one time. So we write a 1 up above. 1 times anything is itself, so 1 times 16 is 16, and we subtract. 19 minus 16 is 3. Now bring down the 7, and continue. 16 goes into 37 twice, because 2 times 16 is 32. Again, we'll subtract, and now we have 5. 5 is not 0, so we have to keep going. We bring down the next digit, which is a 6. How many times does 16 go into 56? Well, if you remember your multiples of 16, they are 16, 32, 48, 64. 48 is less than 56. 64 is too much. So 3 is the next digit that we want. We write the 3 above. 3 times 6 is 18. And when we carry the 1, we find that 3 times 1 is 3, plus the carried 1 is 4. 48, just like we said. Now we'll subtract. 56 minus 48 is 8. Still not a 0, and we have to keep going. So we remember our last of the 3 bullet points. If we run out of digits in the dividend, which is the 197.6, but we still have a remainder, which in this case is 8, add a 0 to the end of the dividend, bring it down, and keep dividing. Okay, so let's do that. We add a 0 to the end of the dividend, we bring it down, so now we want to know how many times 16 goes into 80. Well, the answer to that is 5. So I'll write a 5 above. 5 times 6 gives me 30. I write a 0 and carry the 3. 5 times 1 is 5, plus 3 is 8. And when I subtract, I find that I finally have my remainder of 0, which I've been looking for this entire problem. So the answer to this question is right up here. We don't need this 0 out front. We call that a leading 0, and in mathematics, any zeros that you have in front of a whole number can be discarded. So the final answer for this problem is 12.35. Okay, let's do one more problem. This problem says, a bag of fertilizer covers 1,250 square feet of lawn. Tim Parker's lawn measures 14,800 square feet. How many bags of fertilizer does he need? If he can buy only whole bags of fertilizer, how many whole bags does he need? So the one thing to keep in mind when you're using division to solve a word problem is that division is repeated subtraction. One way to think about solving this problem is to say, okay, Tim Parker's lawn currently has 14,800 square feet, and currently none of it has any fertilizer on it. So if we write that down, 14,800, what would happen if we use just one bag? Well, one bag covers 1,250 square feet. If we subtract, then we'll know how much of his lawn still doesn't have any fertilizer on it. 0 minus 0 is 0. You can't take 5 from 0, so we borrow from the 8, which makes it a 7. Doing so means we can add 10 to 0, which makes that a 10. 10 minus 5 is 5. 7 minus 2 is 5. 4 minus 1 is 3. 1 minus 0 is 1. So once we apply one bag of fertilizer, now we're left with 13,550 square feet of lawn that still needs to have fertilizer added to it. We can repeat this process. So let's go ahead and do it one more time. We'll apply one more bag of fertilizer, and therefore we're going to subtract 1,250 again. 0 minus 0 is 0. 5 minus 5 is 0. 5 minus 2 is 3. 3 minus 1 is 2. And 1 minus 0 is 1. Okay, so we started with 14,800 square feet of unfertilized lawn. We applied 2 bags of fertilizer, and now we're left with 12,300 square feet of unfertilized lawn. We could continue this process until we got all the way down to the end, and then counted the number of times we subtracted 1,250. That would tell us how many bags of fertilizer we needed until we got to a point where there was no unfertilized lawn left. But that process can be very long and tedious, depending on what the numbers are. And that is one of the reasons why division is so useful. If you find that in a word problem, that one way to solve it is through repeated subtraction, then it's very likely that division is the most efficient way to get your answer. In this particular problem, we want to know how many times 14,800 is divided by 1,250. Said another way, how many times can we take 1250 out of 14,800? So let's write it. We have 14800, and that's being divided by 1250. Okay, now these are rather large numbers, so we may find that some of our long division steps here are a little bit tricky, but I think we can do it. So let's begin. How many times does 1250 go into 1? Well, it doesn't, because 1 is smaller than 1250. 1250 doesn't go into 1, it doesn't go into 14, and it doesn't go into 148. So right off the bat, we've got 3 zeros up front, and we won't actually get any digits until we consider 1480. How many times does 1250 divide into 1,480? Well, 1250 is just a little bit less than 1480, so the answer to that is once. We write a 1. Now, before we lose track, let's go ahead and place a decimal to the right of 14,800 and a decimal directly above it. Now we can resume. 1 times 1250 is 1250, because 1 times anything is itself. And we can subtract. 0 minus 0 is 0, 8 minus 5 is 3, 4 minus 2 is 2, 1 minus 1 is 0. No need to write a leading 0, because we disregard those in mathematics. Let's bring down the 0. Now, we want to know how many times does 1250 divide into 2300? Well, it's either once or twice. I'm not really sure which. So let's just try twice and see what happens. Let's step over here to the side of our problem and find out what we get when we multiply 1,250 times 2. We're hoping that the result is equal to or less than 2,300. But since we don't know, we just have to try and see what we get. 2 times 0 is 0. 2 times 5 is 10, so we write the 0 and carry the 1. 2 times 2 is 4, plus the carried 1 is 5. 2 times 1 is 2, so we have 2,500. Well, apparently 2 won't work, because 2,500 is larger than 2,300. If 2 won't work, at least we know that 1 will, because 1250 is less than 2,300. So let's write the 1. 1 times 1250 is still the same 1250 we got in the line above, so we can write that there and subtract. 0 minus 0 is 0. Now here we can't take 5 from 0, but here's a little trick in math. Consider it 2 digits at a time. Instead of trying to take 5 from 0, try to take 25 from 30. You can probably figure out that 30 minus 25 is 5. So we'll write the 0, 5 there. 2 minus 1 is 1. Here's our checkpoint. We notice that we're left with 1050. Since that is less than our divisor of 1250, we know that we have not made any mistakes, and we continue. But 1050 is not 0, we didn't get a remainder of 0, and we need to continue our division. So as was the case with the previous problem, we add a 0 to the end of our dividend, bring it down, and continue. Okay, so now we need to know how many times 1250 divides into 10,500. This is another tricky one. We're not really sure what the answer is. Let's just use some estimation techniques. So we've got 1250. We know that when we double 1250, in other words, when we multiply it by 2, that's going to give us 2,500. Well, 2,500 is just 25 with 2 zeros at the end of it. And if we were to double that, 25, that gives us 50. And if we were to double that, that gives us 100. Now we still have those 2 zeros at the end. So let's think about what we've got. We doubled it, and doubled it, and doubled it. 2 times 2 times 2 is 8. And what we ended up with was 100 with 2 zeros at the end of it, which is 10,000. Now 10,000 is just a little bit less than 10,500. That seems to indicate that maybe 8 is the right answer. Let's try. We'll write an 8 here, and do our long multiplication. We should get 10,000 if we didn't make a mistake. So 8 times 0 is 0. 8 times 5 is 40. We'll write that 0 and carry the 4. 8 times 2 is 16, plus the carried 4 is 20. So we write a 0 and now carry a 2. 8 times 1 is 8, plus 2 is 10. Look at that, 10,000, just like we estimated. Okay, now we can subtract. 0 minus 0 is 0, 5 minus 0 is 5, and 10 minus 10 is 0. No need to write any leading zeros to the left of 500. But again, 500 is not 0, so we're still not done with this problem. Sometimes long division can take a while. Let's add another 0 to the dividend and bring it down. Okay. Well, if 8 times 1250 gives us 10,000, and 5,000 is half of that, then theoretically we should only need 4. So let's give 4 a try. 4 times 1250. 4 times 0 is 0. 4 times 5 is 20. I'll write a 0 and carry a 2. 4 times 2 is 8, plus the carried 2 is 10. So I'll write a 0 and carry a 1. 4 times 1 is 4, plus the carried 1 is 5. Look at that, exactly 5,000. We can subtract, and finally we have a remainder of 0. So, the answer to the first question, how many bags of fertilizer does he need, is right here. It's the quotient of our division problem, which is the answer. He needs 11.84 bags. So 11.84 bags is more than 11 bags, but not quite 12 full bags. Now we want to answer the second question, which is, if he can buy only whole bags of fertilizer, how many whole bags does he need? Well, 11.84 is more than 11, which means 11 is not enough. But it's less than 12. 12 is too much, but he doesn't have a choice. He can either have 11, which isn't enough, or 12, which is enough but a little bit too much. So the right answer to the second question is 12 bags. Alright, I hope that gives you a better understanding of how to use division with decimals. Thanks for listening.